In this video, we will study permutation with identical items but with replacement. And we have to underline this with replacement because it's very important. It changes this formula completely, and that is of n objects taken m at a time. And we have this first question: how many distinct 7-letter words can be formed from 3 A's and 4 B's in order and with replacement? So we have this word here composed of 3 identical letters and 4 identical letters B, and the total number of letters in this word is 7. So with replacement means that object A can repeat more than 3 times and object B can repeat more than 4 times in the 7-letter generated sequence. So let's see, we may have 7 A's or 6, 5, 4, 3 A's here, 2 A's here, 1 A, or no A's. And the same is applicable for B. So we have here 7 B's, 6, and so on until we get 1 B. And now we write the corresponding permutation for each word. So for the first word we have this permutation, it's only 1. For the second word we have 7, and we continue doing that until the end. Now we can add them together and get the total permutation is 128, and that is equal to 2 to the power of 7. So what is 7 here? It is the total size of the generated sequence, so 2 to the power of n. So here we have m is equal to n and equal to 7. So now we have permutation with replacement of 7 objects taken 7 at a time with 3 and 4 identical items, and that is equal to 2 to the power of n, or 2 to the power of 7. So let's define S as the number of distinct letters. So we have A and B, and the number of distinct letters is only 2. So now we can write permutation with replacement of n objects taken n at a time with A and B identical letters is equal to the number of distinct letters raised to the power of n. And we notice that we can write 2 to the power of 7 using this series here, and we can replace 7 with n, and we can get this general formula here. This is not our subject here, but we can just mention it. Now, as a reminder on how to read this formula, so this is permutation with replacement of n objects taken m at a time with A identical objects, B and C identical objects, and we write here semicolons in order to separate the identical items from the manipulated objects, and we can read it permutation with replacement of n objects taken m at a time with A, B and C identical items or objects. The second question is how many distinct 8-letter words can be formed from 3 A's, 4 B's in order and with replacement. So we have here this word composed of 7 letters. We have 3 identical letter A and 4 identical letters B, and the total number is 7 letters. However, the size of the generated sequence is 8, so it's bigger than the 7-letter word. So we are generating 8-letter word, which means we may have 8 A's or 7, 6, 5, and so on until we have either 1 A or no A's. and the same is applicable for the letter B. So now we are going to write the corresponding permutation for the first word and the second and the third and so on. And now we add them together and we get the total number of permutation 256, and this is equal to 2 to the power of 8, and 8 is the size of the generated sequence. So now we can say permutation with replacement of 7 objects taken 8 at a time with 3 and 4 identical items is equal to 2 to the power of 8 or 2 to the power of m, where m is the total size of the generated sequence. This is 8 here. So we can write that as follows, and we can say permutation with replacement of n objects taken m at a time with identical object a and b is equal to s to the power of m. And what is s here? It is the total number of distinct objects. So if we have a and b distinct objects, then s is going to be equal to 2. And if we have a, b, c and d distinct object, then s will be 4, and so on. Question number 3. How many distinct 4-letter words can be formed from 2 A's, 1 B, 1 C in order and with replacement? So we have 2 A's and 1 B and 1 C, and the total number of letters in this word is 4, and the total number of letters in the generated sequence is equal to 4, or we can say that the generated sequence length is equal to 4. So let's see now the total number of possible words we can have. So we may have A with B, and we may get these 3 possibilities here. That's without order, and after that we will permute them and we will get them all in order. So we can have A with C, and we have 3 words. We can have B with C, and we have 3 words. Or we can have only A, or only C, or only B. Or we can have A and B and C together, and we have 3 words. Now let us write the total number of permutation for each word. So for this word here we have this permutation in order, and for this word we have this permutation, and so on until we finish all of them. Now we add this permutation together and we get 42. We add this permutation together and we get 39. Now we add 42 plus 39 and we get 81. So what is 81? It is 3 to the power of 4. What is 3? 3 is the total number of distinct letters, and 4 is the size of the generated sequence, which is composed of 4 letters here. Finally, another way of writing this permutation formula with replacement with A, B, and C identical objects, we can write it as equal to A to the power of 0 plus B to the power of 0 plus C to the power of 0, all raised to the power of m. So if we have here 3 set of identical items, then we are going to have here 3, 1, which means we have 3 to the power of m. Thank you for watching and have a good day.